4.4 Differences of two squares. If we look at example 1, we are finding each product as a binomial. So when we do this, we are actually going to be writing our two binomials into one single binomial. So we're going to multiply them, or we can use a formula, one of the two things, in order to do this. So if we look at example 1a, we have x plus 3 times x minus 3. We look to see that our a is the same in both sets of parentheses. Our a is both x and both, and then our b is both the same as well, which is 3. So we see that we have opposite signs between that a and that b in both sets of parentheses. So we can literally rewrite this as a squared minus b squared. So we said that our a was 3, our a is x, our b is 3. So we're just going to plug those values in. So we're going to have x squared minus 3 squared. X squared is x squared, and 3 squared is 9. That negative out front is going to stay negative, and we're just going to have x squared minus 9. For b, we have 2n plus 5 times 2n minus 5. So again, our a is the same, our b is the same. Our a is that 2n, our b is that 5. We have opposite signs here, so we can use a squared minus b squared. So we're going to plug in our values. So we're going to have 2n to the raised to the second power minus b, which is 5, raised to the second power. So 2n squared is going to be 4n. Remember, it's 2n times 2n, so 4n squared minus, and then 5 squared is 25. So 4n squared minus 25. For c, we have 5x minus 3y times 5x plus 3y. So again, pull out your a. We have a is 5x, our b is 3y. We're going to use the formula a squared minus b squared, because remember, opposite signs, a's and b's are the same. Plug in. So we're going to have 5x raised to the second power minus 3y raised to the second power. That 5x raised to the second power is 25x squared, minus that 3y raised to the second power is 9y squared. So 25x squared minus 9y squared. For example 2, we're writing each product as a binomial again, except now we have one of our terms, either our a or our b, as something that's already having a power to it. So remember, when we're raising a power to a power, we are multiplying those powers. If we look at example a, we have a squared minus 2b times a squared plus 2b. So again, our a is the same, our b is the same, so a is a squared, our b is 2b. Plug this into your formula, which is a squared minus b squared, because opposite signs. We're going to have a squared raised to the second power minus 2b raised to the second power. So this a squared raised to the second power is a to the fourth power. Remember, multiply the 2 times the 2. And then we're going to have negative 2b raised to the second power. So the 2b raised to the second power is going to be 4b squared. So a to the fourth minus 4b squared. For b, we have xy plus z squared times xy minus z squared. So your a is xy, your b is z. Your formula that you're using, because you have opposite signs, is a squared minus b squared. So substitute these values in. We're going to have xy raised to the second power minus z squared raised to the second power. Remember the z squared. There we go. So we have xy times xy, which is x squared y squared. And then we have z squared raised to the second power. So z squared times z squared is z to the fourth power. So x squared y squared minus z to the fourth power. When we are factoring these, we are just working backwards. So if we look at example 3, we already have our binomials. We need to turn it into two binomials multiplied by each other. So we see here that we can take the square root of that a, we can take the square root of the b, and we have a negative between the two terms. If that is the case, find your a, find your b by taking the square root of both terms, and then use the formula a minus b times a plus b. So our a is the square root of x squared, which is x. Our b is the square root of that 49, which is 7. We have a negative between those two, so we can use the formula a minus b times a plus b. So substitute in your values. We're going to have x minus 7 times x plus 7. And we could actually write this as x plus 7 times x minus 7 as well. They're both the same thing. It doesn't matter the order, just as long as one's positive, one's negative. If we look at example B, we have 16 minus 9x squared. We're factoring this. So can we take the square root of that 16? Yes. Can we take the square root of that 9x squared? Yes. So find your a and your b. Your a is the square root of the 16, which is 4. Your b is the square root of the 9x squared, which is 3x. Because there's that negative between the two numbers, use the formula a minus b times a plus b. Plug in your values. You're going to have 4 minus 3x times 4 plus 3x. For C, we have 81a squared minus 25x to the 6th power. We can take the square root of that 81a squared. We can take the square root of that 25x to the 6th power. Find your a and your b. Your a is the square root of the 81a squared, which is 9a. Your b is the square root of the 25x to the 6th power, which is 5x cubed. There is a negative between the two terms, so use a minus b times a plus b. We're going to have 9a minus 5x cubed times 9 plus 5x cubed. If we look at our next example, we have 16r to the 4th power minus 625. So ask yourself, can you take the square root of the 16r to the 4th power? Can you take the square root of the 625? The answer is yes to both of them. So find your a and your b. Your a is the square root of the 16r to the 4th power, which is 4r squared. Your b is the square root of the 625, which is 25. From here, use a minus b times a plus b. The 4r squared goes in for a, so 4r squared minus b, which is 25. And then 4r squared plus 25. Now, if you look at this, this can still be factored. The 4r squared minus 25. You can take the square root of the 4r squared. You can take the square root of the 25. So keep factoring. Your a is the square root of the 4r squared, which is 2r. Your b is the square root of the 25, which is 5. So use your formula again, a minus b times a plus b. This is going to give you 2r minus 5 times 2r plus 5. And you remember you got to bring down that 4r squared plus 25. Remember, you cannot factor that 4r squared plus 25 because there's not a negative between those two terms. If there was a negative between those two terms, then you could factor. But since there's not, you cannot factor.